Hello my dear friends, welcome back to our YouTube channel. This is your ADC Max. This is the continuation of the standard results in the Z transforms. As already we have seen, the Z transform of A power n is Z by Z minus A, and the region of validity is the region of convergence is mod Z greater than mod A. Suppose if we know this result, then we can easily get the third one, the Z transform of e to the power an. So this is my given input. So this can be rewrite Z transform of e to the power a whole power n. So this is the constant now. Looks like a, here is e to the power a. So by using this result, we will get the answer. It's just like that. Z by Z minus e to the power minus a. This is e to the power a, and the region of convergence nothing but mod Z is within mod e to the power a. That's a very simple concept. So once we know this one, it's very good. As well we know that what is Z transform of 1 is Z by Z minus 1. What is Z transform of 2 power n is nothing but Z by Z minus 2. Yeah, by putting a equal to 2. Mod Z is within mod 2. That's right. So this is the idea of when we are going to know the general results, we can easily get those things. It's simple. And this is the a to the power n concept. Now what about the Z transform of n? Polynomial function n. Polynomial function n. So what is the Z transform of n? Let us see the fourth result. Let us see the fourth result. What is the Z transform of n? The polynomial result. N is a polynomial result, right? So by using the definition, here x of n is equal to n. So sigma n equal to 0 to infinity n into z power minus n. Now if you substitute n equal to 0, we get it is 0 into z power 0 is 0. So let us leave it. By putting n equal to 1, we get it is 1 into z power minus 1. By putting n equal to 2, we get 2 into z power minus 2. By putting z equal to 3, we get 3 into z power minus 3 plus 4 into z power minus 4, etc. It's going like that. It's going like that. Is right? It's clear? Now, what does it mean that nz power minus 1 means 1 by z? So 1 by z plus 2 into 1 by z to the 4 square plus 3 into 1 by z whole power 3 plus 4 into 1 by z whole power 4, etc. up to infinity. But already we know in the binomial expansion, it's once the power is 2, 3, 4, then here we have some constant term. As we already know that what is the binomial expansion? Looks like 1 plus 2x plus 3x squared plus 4x cubed plus etc. up to infinity is equal to 1 minus x whole power minus 2. You see that when we have the powers, 1 means here 2, 2 means 3, 3 means 4, continue like that. So this is looks like the binomial expansion, 1 minus x whole power minus 2. So here what is x? Here x is equal to 1 by z only. So let us rewrite this into this model. What's it mean that starting from 1 here, so can I write 1 by z outside? So the balance is 1 plus 2 into 1 by z plus 3 into 1 by z whole square plus 4 into 1 by z whole power 3 plus etc. up to infinity. Once I see that here 4 means here 3, here 3 means here 2, here z 2 means here 1, here 1. So this looks like exact this model. So here z is equal to this x equal to 1 by z. So when we write this is equal to 1 minus x, here 1 by z is the x whole power minus 2. What's the reason of validity here? Mod of 1 by z is less than 1. So by that way, mod 1 is less than mod z, otherwise mod z is greater than mod 1. So this is the reason of convergence. Let us rewrite and simplify this, we get the answer. So 1 by z into, let us take in the LCM of this one, what we get? We get z minus 1 by z whole power minus 2. So minus 2 can make the reciprocal, what we get? We get is 1 by z into z squared by z minus 1 whole square. After reversing, making the square in the numerator denominator, because of I want to cancel 1 z, so we get z by z minus 1 whole square. So this is the z transform of n. What's z transform of n? Z by z minus 1 whole square if mod z is greater than mod 1. Is right? So this is the polynomial function n. What is z transform of n? Z by z minus 1 whole square. The reason of convergence is nothing but mod z greater than mod 1. This one. Can you tell me what is the 1 by n? Yeah, is it possible to get 1 by n? Yeah, the same idea only 1 by n. So let us see that 1 by n. So how we will get the 1 by n? So now it is the place of x of n is 1 by n. But when substitute n equal to 0, what happened? Anything by 0 becomes infinity, isn't it? So to avoid this case, let us start the summation from the 1, n equal to 1 onwards. Because of when n equal to 0, 1 by 0 becomes infinity. So to avoid this case, the condition was n is always positive. If n is always positive, it's very important. If n is always positive, right? Clear? So sigma n equal to 1 to infinity, 1 by n is at power minus n. Let us substitute n equal to 1, we will get it is 1 z power minus 1. Putting n equal to 2, we get it is 1 by 2 z power minus 2. Putting n equal to 3, we get 1 by 3 z power minus 3. Putting n equal to 4, we get 1 by 4 z power minus 4 plus etc. up to infinity. I think so this is something is different because the denominator it has some constants 2, 3, 4. But as you looks like the binomial expansion, the constants are in the numerator only, it's product form. But this not looks like the numerator, it's the product form, particularly in the denominator side. So we can't able to use the binomial expansion. So already we know this result is there. What is the log of 1 plus x is equal to x minus x squared by 2 plus x cubed by 3 plus x power 4 by 4 etc. etc. Right? Here we have yes plus only, no problem, but here I have plus or minus. Plus or minus. Power 2 means power 2, 3 means 3, 4 means 4. I think this similarly looks like that only, no problem. But I think all are plus. All are plus means this result is there. It's called minus log of 1 minus x is equal to 1 plus, that is x plus x squared by 2 plus x cubed by 3 plus x power 4 by 4. And the reason of the convergence is minus 1 less than x less than 1. So what about here? Here x is equal to 1 by z power minus 1, that is z power minus 1. So can we use the same result here? We get this in the place of x is equal to, in the place of x is equal to z power minus 1. So minus log of 1 minus z power minus 1. So 1 by z by using this result is equal to minus log of z minus 1 by z. Otherwise, by using the power rule, what we'll get is z minus 1 by z whole power minus 1. So by using the power rule, make the reciprocals. So this everything is the natural logarithm. So it is log to the base e of z by z minus 1. So this is the z transform of 1 by n. And the reason of validity is minus 1 less than z less than 1. Minus 1 less than z less than 1. Otherwise mod z greater than 1 as you said. Right? So this is the z transform of 1 by n value. 1 by n value. What about z transform of 1 by n plus 1? Can we go for z transform of 1 by n plus 1? Let us see. Z transform of 1 by n plus 1. So the fifth result, Z transform of 1 by n plus 1. If it is n plus 1, by putting n equal to 0 doesn't matter. Going for the n equal to 0 doesn't matter. So n equal to 0 is not matter. Because putting n equal to 0 we get, it is 1 only. So n equal to 0 onwards now. Here it is n plus 1. So let us rewrite this into the infinite series. What we will get? By putting n equal to 0, we get is 1, z power 0. Z power 0, what is z power 0? 1 only. So z into z power 0 is 1 only, no problem. Putting n equal to 1, we get is 1 by 2. Z power minus 1. Putting n equal to 2, we get 2 plus 1, 3. So it is z power minus 2. Putting n equal to 3, we get 1 by 4. Z power minus 3 plus etc. etc. up to infinity. So once again, this is nothing but 1 only. This is nothing but 1 only. So it is 1. 1 plus 1 by z. 1 by 2 into z power minus 1 plus 1 by 3 into z power minus 2 plus 1 by 4 into z power minus 3. But unfortunately what we are going to do that, I am going to use the same logarithmic concept, but the power 2 means here also 2, power 3 means here also 3, they are an equal number, they are an equal. So but here it is not like that. Here we have power minus 1, here we don't have it. Here we have power 2 means here we have 3. So I want to make 2 means here also 2, 3 means here also 3, 4 means here also 4. So what I suggest you that multiply and divide by z. So when I multiply one z and divide one z, what we get is 1 by z. Otherwise z power minus 1. Is that right? When multiply and divide, so multiply and divide, what we'll get is we include 1 by z to each term. This is z power minus 1 on both these sides. Z power minus 1 means 1 by z. So multiply and divide. So what we'll get is 1 by 3 into z power minus 3, 1 by 4 into z power minus 4. Now this is looks like the same model as that we are seeing there. Is right? So this is equal to z into minus of log of 1 minus x. So 1 minus z power minus 1, otherwise 1 by z. Right? So is equal to minus z of log of z minus 1 by z. By using the power rule, we get this z into logarithm base e, natural logarithm of base e. Make the reciprocal, so z by z minus 1 whole power minus 1. Otherwise, you go on z minus 1 by z whole power minus 1 by using the power rule. Now using the power rule, we get this z into log of the base e z by z minus 1. So this is the z transform of 1 by n plus 1. The region of validity the same thing, it is minus 1 to plus 1. The z lies between minus 1 to plus 1. Right, sir? So this is the way to determine the various polynomial functions under the z transform. Suppose when we have the factorial functions in the denominator, when we have the trigonometric functions, what we can do? Let us go to watch and make a separate video for the factorial functions as well as the applications of the exponential series and the z transforms for the trigonometric series. Sin n theta, cos n theta. Please go and watch a separate video I made for those functions under the z transforms. So thank you so much for watching our YouTube channel ADC Max. Thank you so much.